Hi Math 9s, I wanted to take some time today to go through the practice questions that I gave you for our chord topic this week. Just like usual, these questions are from our textbook, but I've kind of picked out a few that I'd like you to work through. And just like always, the answer key is at the back, at the end of the document. But I'd like to go through and give you guys some explanations and tutorials on how to work through some of these problems. So let's jump right in with number 3. So it tells us point O is the center of each circle. Determine the values of D, E, and F. So if we look at part A, we're looking for angle D right here. So remember, this is our chord. It looks to me like this is a perpendicular bisector because it's cutting our chord into 2 equal parts. So it's in the name for us. Perpendicular bisector means that this angle here is 90 degrees. It's a right angle. For part B, it looks like we have a chord right here, and it looks like we have a line that is making a perpendicular right angle there from the center of the circle. So we know that this side of the line and this side of the line, or the sides of the chords, are going to be equal. So E is equal to 5. And for C, it looks as well like they've given us a perpendicular bisector on a chord. So if the whole chord is 14, that means that side F is half of that, or 7. For number 4, we're trying to find the values of each angle. So it looks like, again, we're going to do it in green. There's our chord from O, the center. There's our perpendicular bisector because it's cutting it into 2 equal parts. So that means that angle Y is 90 degrees. X, well, let's take a look here. So if this side of the line is 90, this side is also 90. And remember, the angles inside a triangle, interior angles, add to 180. So if I'm looking at this triangle that I've outlined in green, I have 40 degrees, I have 90 degrees. So if I go 180 minus 90 minus 40, it will give me X, and X is equal to 50 degrees. For B, this one's a little bit trickier. So they tell us in this triangle here that we have 22 degrees there. You can also see from O to D is a radius. O is the center, and it goes to D on the edge. So that's a radius. O to E is also a radius. So you know that these two sides are the same length. That means that it's an isosceles triangle. So that means if we have two sides that are the same length, we have these two angles here that are also going to be the same size. So X is equal to 22 degrees. To find Y, we can now go 180 minus 22 minus 22, which gives me, I can't do that in my head, so bear with me for 1 second. Gives me 136 degrees. So Y equals 136 degrees. For C, C is actually really similar to B. So again, we have O to F and O to G. They're both radii. So if these sides are the same length again, that means that angle Y and angle X are going to be equal. Now they tell us that this angle here is 110. So if I go 180 minus 110, that leaves me with 70 degrees. And the 70 degrees that are left over have to be split equally between X and Y. So 70 divided by 2 means each angle, X and Y, are 35 degrees. For number 5, it looks like now we're trying to find side lengths. So point O is the center of the circle, just like always. Determine each value of A and B. So if I'm looking here at part A, I see a triangle here, and we have our right angle there. I have the hypotenuse, which is 10. I have a leg, which is 3. So if I go square root of 10 squared minus 3 squared, I'm skipping a lot of steps for my Pythagorean theorem because we should know how to do that by now. Bear with me while I punch this into my calculator. I get, so 10 squared minus 3 squared, and then I took the square root of that. I got A equal to 9 point, I'll round to the 10th because I don't think it tells me otherwise. I'll say 9.5. And if I know that this side here is 9.5, remember this is our perpendicular bisector, so length A and length B are going to be equal. So B is also equal to 9.5. Same thing here with finding this side A. So I'm going to go ahead and use Pythagorean theorem. So A equals the square root of 7 squared minus 4 squared. Remember your hypotenuse is the opposite side from the 90-degree angle. So A is square root of 7 squared minus 4 squared. 5.7. So A from point P to point M is 5.7. For B, we're trying to find the whole chord. When we found A, we found half. To find B, we need to multiply that by 2 to get me 11.4. For question 6, again, point O is the center of the circle. Determine the value of B. Where is B? B is this side right here that I'm going to highlight in green. All right, so I have my 90-degree angle there. I know this side is 5. And I know to find a side, I need to use Pythagorean theorem. So I need to use a triangle. Well, one way we could do that, look here. We know from here to here is half of the diameter. They gave us the diameter here of 18. O to Q is a radius, so it's half of that. So the radius is 9. I can go ahead and I can actually draw a radius from point O to point R like that, and I can label that 9. So I end up with a triangle. I'm just going to sketch it over here, where the hypotenuse is 9, this leg is 5, and B is the missing side. So B is going to be the square root of 9 squared minus 5 squared. 9 squared minus 5 squared. And to the nearest 10th is 7.5. Point O is the center of each circle. Determine each value of R. Which extra line segment do you need to draw first? Justify your solutions. So justify your solution just means like use math to support it. So if I'm looking at A, they give me a radius here from O to D, and it's 3, so that's great. So if I'm drawing in a line segment to make a triangle, I am probably going to draw a radius from O to B, and that would also be length 3. So now I have a triangle that looks like that, and you're trying to find that length there. So again, I would use Pythagorean theorem. I'm going to go A equals the square root of 3 squared minus 2 squared. So A is equal to 2.2. For this example here, for B, they've given us a diameter. So diameter from T to V, which is 20. So the radius is half of that. The radius is T to O, 10. Perfect. We are trying to find the length of R, which is this guy here. So we're trying to find the length of the perpendicular bisector. So if I'm turning this into a triangle, I would probably draw a radius from there to there, label that as 10. I'm trying to find this side here. This side is half of my chord because it's our perpendicular bisector. So it's going to be half of 16, which is 8. So now I have a triangle that looks something like this. I'm going to call this A to match our Pythagorean theorem. Here I have 10, and here I have 8. So again, we're just going to use Pythagorean theorem. So A equals the square root of 10 squared minus 8 squared. Which gives us a length of 6. Or I guess for our solution, we should be using R. And yes, of course, I could have drawn the triangle over here this way. It would have worked out the exact same way. It really just depends on what your brain likes to do. Number 10 is a little bit trickier. So we're trying to find S. And S is, oh, it looks like this line segment here. From O to C. Okay. Well, there's a lot going on here. I see, let's see, what is important? Well, I see that this here is a chord that's split in half. So this side here is 5. This side here is 5. That could be helpful. We need to make a triangle out of S. Some people might look at S and think, well, it looks close to being the same length as 3, so maybe it's just 3. No. Use math. What if I drew a triangle like that? Ah, well, that involves S now, and it's a right triangle, so that would work. But what is this side here? Well, it's a radius. It goes from O to B. So it's a radius. So the first thing we need to do is find the radius. And in the other problems, they had given us a way to find the radius, either by telling us what the radius is or giving us diameter and having us split it in half. I don't see that listed anywhere or labeled anywhere, but I do see that this right here is a radius. I'm hoping you guys can see that. There's radius right there. Interesting. Is there a way that I can find this missing R? Well, it's part of this triangle here, where I know this side is 3. I have a 90-degree angle. And this side here is half of 11 because it's part of this bigger chord. So this side here is half of 11, or 5.5. So now I can find my radius. So my radius is going to be, using Pythagorean theorem, it's my hypotenuse, so I need to go 5.5 squared plus 3 squared. So let me punch that in. So my radius is 6.3. If you're in high school, you'll learn that you actually really shouldn't round this answer. You should keep as many decimal places as you can. But for grade 9, I'm just going to round it to the nearest tenth for right now. So 6.3. So now that I know my radius is 6.3, that means that back over here, that side is 6.3. Now I have a triangle that involves that side S. And I'll sketch it over here so it looks, I guess I'll keep it the same way. So it looks something like that. There's my 90-degree angle. I know this side is 5. I know this is 6.3. And this is the missing side that I'm trying to find. So now I can use Pythagorean theorem. So S is going to be equal to the square root of 6.3 squared minus 5 squared. So S is equal to 3.8. That's a little bit trickier than what we've done so far. Let's take a look at part B. So B is similar. This time we're trying to find this big side S. Okay. There's a lot going on. There is a lot going on. All right, well, I noticed that if this is a chord here, and there's our perpendicular bisector, this is also a 90-degree angle. So maybe if I can find the length of this side and this side, I can find S. So that could work. This side here, I can figure out pretty easily because it's just half of 6. So that side there would be 3. To find this whole side, I need to figure out what this part is. So let's see if we can figure that out. Let's try to find this. Let me think. Well, I know that part's 3. Aha, look at this here. These two lines are the same length. They're also a radius, which is great. So this side here is going to be equal to 4. So now in my little triangle here, I know 2 sides, so I can find this missing side. So let's do that. I'm going to do it in yellow. I'm going to call this X just because it's the missing side. So X is going to be equal to the square root of 4 squared minus 3 squared. So that missing side X, the square root of 4 squared minus 3 squared, is equal to 2.6. And I'll just leave it to the nearest tenth again. So X is equal to 2.6. That's great. That means that this whole side here is equal to 4 plus 2.6. So that's equal to 6.6. So let me redraw my big triangle there. Just separate so it's a little bit easier to see. So this is 3, this is 6.6, and this is S. So now we can find S. S is equal to the square root of 6.6 squared plus 3 squared, because S is the hypotenuse, so I need to add. So when I plug that into my calculator, I end up with S equal to 7.2. Number 17 here is a little bit trickier. So we have a radar station R, so that's right there. It tracks all ships in a circle with radius of 50 kilometers. Okay, so that's the circle that they've drawn there. There is 50 kilometers away from that radar station. So imagine like, you know, like on those like sonars where you see the line going around and around and it goes like ding, ding. Kind of imagine that that's what's happening there. Okay, so a ship enters this radar zone and the station tracks it for 62.5 kilometers. Okay, so that looks like from here to here is 62.5 kilometers. Okay, so that looks like a chord. What is the closest distance the ship comes to the radar station? Okay, this actually isn't as bad as it seems. So in the whole path of the ship along this yellow line, where is it closest to the radar station at the middle? Well, of course, it's going to be when it's perpendicular to that path. So basically, it sounds to me like we need to find the length of this perpendicular bisector. Okay, well, let's see how this goes then. So, where can we start? Well, we know that this yellow line is 62.5. So, what if I split it into half and I get 31.25 for just this second half of the pathway? Perfect. I can make a right triangle by drawing in a radius. And I know that radius is 50 kilometers. Perfect. So now I have a right triangle that looks something like this. There's my 90 degrees. Here's 31.25. Here's 50. Now I can find this missing side. I'll call it A. And I can find A by using Pythagorean theorem. So 50 squared minus 31.25 squared equals, so square root of 50 squared minus 31.25 squared it gives me a distance of 39.0 kilometers. So the closest distance a ship comes to the radar station is 39.0 kilometers. That's actually not too bad once you figure out what you need to do. All right, let's take a look here at our last one. So for number 18, we have a pedestrian underpass constructed beneath a roadway using a cylindrical pipe with a radius 1.8 meters. And they drew that in for us right here. Perfect, 1.8 meters. The bottom of the pipe will be filled and paved. The headroom at the center of the path is 2.8 meters. How wide is the path? Okay. So we're trying to find the distance from there to there, which guess what? Is just a chord. Okay. Can we make a triangle? Well, yeah, of course. So we know that there is going to be 90 degrees. What if I draw a radius from the center to this point here? Awesome. I know that's 1.8 meters. They already told me that. What if I find this half of my bisector? I'll call that A. All right, but the thing that I'm missing is this green side here. Well, we can find that just using a little bit of subtraction. So if here to here is 1.8 and here to here is 2.8, I can subtract to find the difference. So 2.8 minus 1.8, that's not too bad. That gives me 1.0. So this length here is 1 meter. Now I have a triangle. That side's 1, this side's 1.8, this side is what I'm trying to find. So do some Pythagorean theorem. A is equal to the square root of 1.8 squared minus 1 squared. So A is equal to 1.4966, so I'll just round that to 1.5. Is that my final answer though? No. I just found half of my chord. I need to find my whole chord. So I need to multiply that value by 2, and I get a width of the path equal to 3.0 meters. And there's my final answer. If you have any questions about these, if maybe something didn't make sense or maybe I made a mistake, which is possible, please shoot me an email. I'm super, super happy to help out. Just give me a heads up and let me know how I can support you. Thanks, grade 9s.